All right, we're going to do page 2 now of P3, and we see here they gave us a graph and they wanted us to give kind of a story of what was happening. These were minutes and these were miles over here. So if you kind of look at the slope here, we went 2 miles in 4 minutes. All right, so for the first, we would say the first 4 minutes, 4 minutes, we travel at a speed of 2 miles per 4 minutes. Now that's kind of awkward, right? So if you think about it, it would be like 2 over 4 is 1/2, so a speed of 0.5 miles per minute. If you wanted to put it in something more familiar, you could multiply by 60 minutes and that would be 30 miles per hour. Okay, either one is correct. All right, so for the first 4 minutes, we're traveling at a constant speed. For minute 4 through 6, we're not going anywhere. We're staying put at that 2 miles, right? We are stopped. Okay, and then for minutes 6 through 10, we travel at a speed of, in this case, we went up 4 miles over 4 minutes, so it's 4 miles per 4 minutes. So the speed of 1 mile per minute, or again, if you want to do the more familiar, 60 miles per hour. All right, so that's in a nutshell what this graph is saying. Now this is a distance versus time graph. We got to be clear about what this graph is, because later on we'll do velocity versus time, and that'll mean something different. But we'll get into that more, especially into chapter 2. 57 gave us 2 functions, and we're dealing with what is called composition. So when you deal with the composition, you always want to work on the inside and then kind of work out. So the first thing we see is g of 1. We're going to put 1 into the g function. 1 squared minus 1 is 0. So this is going to be f of 0. G of 1 is 0. So now I'm putting 0 into the f function. And that's going to give me square root of 0, which is 0. So always work inside out. F of 1, put 1 into the f function. I get square root of 1, which is 1. So this is going to be g of 1. And then if I put 1 in there, we did that earlier, we got 0 for the answer for that. F of 0, if I put 0 into the f function, I'm going to get 0 for that. So now I put that answer 0 into the g function. 0 squared minus 1 is negative 1. Put negative 4 into the g function. I'm going to get 16 minus 1, which is 15. So now f of 15, if I put that in there, I get square root of 15. Now there might be a temptation on you to grab your calculator, give me this as a decimal. No need. That's the exact answer. That's the better answer. Just leave it like that. Okay? F of g of x. Now we're being general. We're not putting a value in for g. We're just saying, what if you put the whole stinking g function into the f function? What if you took x squared minus 1 and put it right in there? Well, what you'd have is the square root of not x anymore, but x squared minus 1. And that'd be your answer. Same thing here. G of f of x. What if you took the whole f function and put that into g? Then you'd have square root of x squared minus 1. Now we can go further here. The square root of x squared is just x. So we'd end up with that. So if you have a generic thing like that, take that whole function, put it right inside of there. You're putting it in place of the x. So there won't be that x there anymore. You'll put the whole thing into it, just like you do with the numbers, right? 63 may have thrown you off a little bit. It said f of g of 3. So what we wanted to do is figure out what g of 3 is. So you had to look at the graph to get a visual. So if you look at your graph and you go to 3, you'll notice that g of 3, when x is 3, g looks like it's at negative 1. And now the question is, well, what does the f graph look like when x is negative 1? So if you went over to negative 1 and you go up to your f, it looked like it was at about 4. That would be my guess. Now again, if you're close but you didn't get exactly that, we're not going to panic. The graph was a little hard to read and be precise on. But this is the idea. Did you go to 3 for the g function, get a value, and then did you go to that value for the f to get the corresponding thing? Same thing here, f of 2. When x is 2, what does f look like it equals? And it looked like at 2, f was about -1. So now if I go to -1 for the g function, what does that look like? And that to me looked like it was at -4. All right. AP tests will be very clear. There's no ambiguity on the AP test. So they'll never give you a problem where you're like, I don't know, it looks like this, maybe it's that. You'll always know for sure what where it's supposed to be. All right. And then 64 told us that the radius of a circle was expanding at a rate of 0.6 times time. We know the area of a circle based on its radius is always pi times r squared. So then they wanted us to create this composition here. So basically what they want us to do is to take the r function, this 0.6t, and to put that in for r here. And so that would create pi times 0.6t squared. And if you actually work that out, 0.6 squared is 0.36. So we would end up with 0.36 pi t squared. And what does that tell us? Well, if I have a certain amount of time that has elapsed, I can put that here and then work this out, and that'll actually give me the full area. I don't even have to worry about the radius. In a way, it kind of bypasses you needing to figure out what the radius is first and then finding the area. This just lets you do it all in one shot. So may be helpful for whatever you're doing, but that's how we do it there.